Vacuum decay. Right now, you feel safe. Scrolling, breathing, maybe holding a warm cup of coffee. But the universe above you may be balancing on a flaw no one can see. Everything we know assumes one comforting idea, that empty space is stable, that the fabric of reality has already settled into its lowest, safest energy state. But physics allows for something far more unsettling. What if the universe is only pretending to be stable? What if it's stuck in a temporary condition, a false vacuum? Picture space itself like a stretched surface under tension. It looks calm, feels solid, yet it isn't in its true resting position. And according to quantum field theory, that illusion can fail without warning. Somewhere in the endless darkness, far beyond any telescope, a microscopic bubble could suddenly form. Not a bubble of matter or energy, but a bubble of true vacuum. A region where space finally snaps into its lowest possible energy state. Inside that bubble, physics rewrites itself. The constants we depend on, the strength of electromagnetism, the mass of particles, the rules that allow atoms to exist, simply change. And here's the part that makes this a true kill switch. That bubble wouldn't creep outward. It wouldn't slow down. It would expand at the speed of light. There would be no flash, no shockwave, no final moment of awareness. Nothing in the universe can outrun light, so nothing could warn you. One instant, reality is normal. The next, your body, the planet, the galaxy, every structure ever built by physics ceases to function. Atoms wouldn't burn or explode. They would fail. Matter would lose the rules that hold it together. Information itself would be erased, overwritten by a new version of reality where nothing familiar can survive. This wouldn't be destruction as we imagine it. It would be a phase change, a silent cosmic reboot that deletes the operating system of existence. And the most chilling part? If vacuum decay ever happens, it has already happened somewhere, or it never will. There is no in-between. So if the universe can end without sound, without light, and without warning, what other human-made experiments might be capable of flipping reality's final switch? The Big Rip. Look up at the night sky, and everything appears calm, almost frozen. But astronomers know better. Every distant galaxy is fleeing from us, its light stretched red as space itself expands. For decades, scientists debated how this story would end. Would gravity pull the universe back into itself? Or would expansion simply fade into eternity? Then came dark energy, a force we can't see, can't touch, yet it dominates the cosmos, silently pushing everything apart and accelerating the expansion of space. And if that force behaves in the worst possible way, it leads to a far more violent finale. This scenario is called the Big Rip. In this version of the universe, dark energy doesn't stay constant. It evolves into something far more dangerous, phantom energy, a repulsive force that grows stronger with time, not weaker. At first, nothing seems wrong. Distant galaxies drift away faster than expected. It's subtle, almost boring. But beneath that calm is a countdown no clock can measure. As phantom energy intensifies, it begins overpowering the very forces that hold reality together. Roughly 60 million years before the end, gravity loses its grip on the Milky Way. Our galaxy stretches, thins, and dissolves into billions of isolated stars drifting alone through space. Months before the finale, solar systems can no longer survive. Planets are torn from their orbits. Earth is ripped away from the sun, flung into darkness. With minutes remaining, the planet itself can't hold together. The fabric of space pulls harder than gravity, harder than molecular bonds. Earth is shredded from the inside out. And then, in the final moments, the rip goes microscopic. Phantom energy overwhelms the strongest force in nature, the strong nuclear force. Atomic nuclei rupture. Protons and neutrons fall apart. Matter loses the ability to exist as matter. The universe doesn't explode. It unravels. Every particle becomes isolated, drifting endlessly in an ever-expanding void, unable to interact with anything else ever again. Not a violent death, but an infinite loneliness. And if the expansion of the universe itself can someday tear atoms apart, What happens when humans try to push the limits of space and energy right here on Earth? The Big Crunch. Physics loves symmetry. Every action hints at a reversal. And since the universe began with the Big Bang, an eruption of space and time from a single point, it raises an unsettling possibility. What if that explosion was only the outward breath of the cosmos, and the inhale is still coming? This is the Big Crunch. In this scenario, the expansion of the universe isn't permanent. It's a pause. If the total amount of matter and energy is high enough, gravity eventually wins. Not suddenly, not dramatically. At first, almost nothing seems different. Expansion slows. Then one day it stops. Galaxies hang motionless in space, suspended for a cosmic heartbeat. And then the direction flips. The fall begins. Everything starts moving toward everything else. The universe contracts. The night sky changes in ways no civilization could ignore. Instead of distant galaxies drifting away, they rush toward us. Their light compressed into a violent blue glare. The faint microwave afterglow left behind by the Big Bang grows hotter, brighter. The darkness between stars fills with light. Eventually, the sky burns with the intensity of a stellar surface. As space collapses, pressure skyrockets. Temperatures climb into the billions, then trillions of degrees. Galaxies crash together in unstoppable pileups. Stars collide and merge. Others detonate under forces they were never meant to withstand. Black holes dominate the chaos, merging, feeding, and possibly evaporating as the universe grows smaller and denser by the second. Atoms can't survive. Matter is stripped down to its most fundamental particles. In the final moments, all of space and time is crushed back into a single point. Infinitely hot, infinitely dense. A mirror image of the beginning. And that leaves the most disturbing question of all. Is that the end? Or does the universe rebound, triggering another Big Bang, another reality, another cycle of cosmic death and rebirth? And if the universe itself can collapse back into nothing, what happens when humans try to recreate extreme densities right here on Earth? Heat death. Maybe the universe doesn't end with a scream. Maybe it ends with a whisper that never quite finishes fading. This is heat death, also known as the Big Freeze, and it may be the most unsettling ending of all because nothing breaks. Nothing explodes. Everything simply runs down. The driving force is the second law of thermodynamics. In any closed system, disorder, entropy, always increases. And like it or not, the universe is the ultimate closed system. Fast forward trillions of years. By then, the raw material needed to form new stars is gone. No more stellar nurseries. No fresh light. One by one, the last stars exhaust their fuel and flicker out, leaving behind cold relics, white dwarfs, neutron stars, and black holes drifting through darkness. The cosmos becomes a graveyard. But even that isn't the end. Over absurd stretches of time, the decay continues. Some theories suggest protons themselves may not be eternal. If they decay, every remaining fragment of matter slowly dissolves into radiation. Eventually, only black holes remain, and even they cannot escape entropy. Through Hawking radiation, they leak energy, so slowly it feels impossible to imagine. The largest black holes will take 10 to the power of 100 years to fully evaporate, a number so large it barely fits inside thought. Yet even that clock runs out. When the final black hole fades, the universe reaches its end state. Maximum entropy, perfect uniformity, no structure, no energy gradients, nothing left to power motion, chemistry, or thought. Just a thin, featureless haze of particles and photons, hovering a breath above absolute zero. In this universe, nothing ever happens again. No life, no memory, no cause and effect. Time itself loses meaning because there is no change to measure. Not a death by violence, but by exhaustion. And if reality itself can slowly wind down into permanent stillness, it raises a darker question. Could intelligent beings ever accelerate that process, intentionally or by accident? A rogue black hole. Space looks empty, but it isn't calm. It's a shooting range. And our solar system is a small, fragile target drifting through it. While we obsess over asteroids, far larger threats roam the darkness, rogue black holes. These are black holes that were violently ejected from their home galaxies, sent wandering through interstellar space with no warning and no light. Our own galaxy may contain millions of them. Invisible, silent, moving faster than anything that feels safe. You would never see one coming. Black holes don't glow. They don't reflect light. The only way to detect them is by watching how they bend everything else around them. If one were headed toward our solar system, the first clue wouldn't be a headline or a telescope image. It would be subtle. A strange wobble in the orbit of Neptune. A slow distortion in Uranus' path. By the time astronomers realized what was causing it, the countdown would already be over. A near miss would still be catastrophic. A black hole drifting through the outer solar system could yank planets from their orbits, flinging them into deep space. Earth could be exiled from the sun, doomed to freeze in eternal night. But a closer pass would be absolute chaos. The black hole's gravity would overwhelm the delicate balance holding the planets in place. Orbits would collapse. Worlds would scatter. If Earth crossed the danger zone, the outcome would be nightmarish. The side of the planet facing the black hole would feel a far stronger pull than the far side. The planet would stretch, crack, and melt, drawn out into a glowing filament of rock and metal, a process known as spaghettification. Earth wouldn't explode. It would be pulled apart. Its remains would spiral into the black hole's accretion disk, releasing a brief, violent flash of X-rays, the final signature of a world that simply existed in the wrong place at the wrong time. And if random cosmic wanderers can erase planets without warning, what happens when humans begin creating gravity traps of their own? A gamma-ray burst. If the universe has a trigger that can be pulled without warning, this might be it. A gamma-ray burst, known as a GRB, is the most powerful explosion ever observed. Nothing else even comes close. GRBs are born when massive stars collapse into black holes, or when neutron stars collide in violent mergers that warp space itself. In just a few seconds, a single burst releases more energy than our sun will produce over its entire 10 billion-year lifetime. And that energy isn't spread out evenly. It's focused. Two impossibly narrow jets erupt from the explosion, blasting outward at nearly the speed of light, like cosmic laser beams designed to kill entire regions of space. If one of those jets were aimed directly at Earth, distance wouldn't save us. Even from thousands of light years away, the damage would be immediate. The first sign would be strange. A sudden, blinding flash in the sky from a star no one ever marked as dangerous. No buildup. No warning. Seconds later, high-energy gamma rays slam into the upper atmosphere. They tear nitrogen molecules apart, triggering chemical reactions that produce nitrogen oxides, compounds that rapidly shred the ozone layer. Within hours, Earth's protective shield is gone. The sky darkens with a brownish haze of nitrogen dioxide. And then the real damage begins. Unfiltered ultraviolet radiation from the sun floods the surface. Oceans are hit first. Plankton, life at the base of the food chain, is sterilized. Ecosystems collapse upward. On land, acid rain poisons soil and water. Any survivors face a second assault, a lingering shower of cosmic rays that penetrates deep into living tissue, damaging DNA and cells beyond repair. The planet itself remains intact, but life does not. A gamma-ray burst wouldn't crack Earth apart. It would simply erase the biosphere, silently, invisibly, and almost instantly. And if nature can unleash that kind of focused energy across the galaxy, what happens when humans begin experimenting with forces that push energy into similarly extreme concentrations? Collision with the Andromeda Galaxy. On a clear, moonless night, if you know exactly where to look, you can spot a faint, misty smear of light in the constellation Andromeda. That dim patch isn't a cloud or a trick of your eyes. It's an entire galaxy, our nearest major neighbor, and it's coming straight at us. The Andromeda Galaxy sits about 2.5 million light-years away. It contains roughly 1 trillion stars, and right now, It's racing toward the Milky Way at around 110 kilometers per second. This collision isn't speculation. It's destiny. In roughly 4.5 billion years, the two galaxies will meet. Unlike most cosmic catastrophes, this one won't arrive in an instant. It will unfold in slow, magnificent terror. As Andromeda draws closer, gravity begins reshaping both galaxies. Their supermassive black holes start orbiting each other, locked in a gravitational dance that distorts space itself. Vast tidal streams of stars and gas are ripped from their galactic homes and flung into intergalactic space. The night sky transforms. What was once darkness becomes a living mural, spiraling star fields, glowing nebulae, and two galactic cores growing brighter with every passing million years. Actual star-on-star collisions are rare. Space is too vast for that. But gravity doesn't need direct hits to cause devastation. The chaos destabilizes solar systems. Orbits stretch, tilt, and break. Our own solar system could be thrown clear of the merged galaxy, cast into the void between galaxies, drifting forever without a home star cluster. Or it could be hurled inward, toward the newly forming galactic core, where radiation is intense and the merged black holes spiral toward each other in a violent endgame. The merger takes hundreds of millions of years to complete, eventually settling into a single massive elliptical galaxy, already nicknamed Milkomeda by astronomers. Humanity likely won't be there to witness it, but the cosmic reshaping of our entire galactic neighborhood will be the grandest transformation this region of the universe will ever experience. And if entire galaxies can collide and rewrite cosmic history, what happens when the threat doesn't come from the heavens, but from experiments conducted right here on Earth? A strangelet incident. In the shadowy corners of theoretical physics, there exists a terrifying possibility: strange matter. A bizarre form of quark soup, made of up, down, and strange quarks. It may be more stable than the matter we know. A strangelet is just a microscopic fragment of this material. But tiny doesn't mean harmless. If a strangelet were to touch an ordinary atom, theory predicts the atom would instantly convert into strange matter. One nucleus becomes two, then four, and so on. Each conversion releases energy and spawns more strangelets, sparking a chain reaction that could propagate across a planet. Imagine Earth itself as the target. A single strangelet landing anywhere could begin transforming the planet from the inside out. Rock, water, air, even life, all rewritten into a dense, exotic matter. The process would move astonishingly fast. In minutes, the planet could shrink, compressing into a hyperdense sphere only a few dozen meters across. A quark star born from the remains of our world. Where could such a particle come from? Perhaps a rare collision of neutron stars, flinging strangelets across the galaxy. It's an extreme and highly speculative scenario. Yet it represents one of the most complete forms of annihilation imaginable. Not just death, not just destruction, but a rewriting of matter itself. And if reality can be flipped at the level of atoms, could human experiments ever stumble across a trigger we are not meant to touch? Reversal of the cosmological constant. We've long believed that dark energy, represented by the cosmological constant, is steadily pushing the universe apart. But what if that constant isn't constant at all? What if this mysterious energy field is unstable, capable of suddenly changing its value? Some theories in quantum gravity and string theory suggest it's possible. And if it happens, the results would be immediate and absolute. If the cosmological constant flipped from a positive, repulsive force to a negative, attractive one, the universe wouldn't just slow its expansion. It would violently reverse. Space itself would collapse everywhere at once. This wouldn't be the gradual contraction of a big crunch. No, this would be an instantaneous, universe-wide implosion. From every point in existence, space-time would rush inward toward every other point. Galaxies, stars, planets, and atoms would all be crushed simultaneously into a singularity. There would be no warning, no escape. Unlike the Big Crunch, which raises questions about coordination across vast distances, This collapse is local, yet simultaneous everywhere. Every corner of the cosmos implodes in unison. It is the ultimate kill switch, a cosmic off button flipped without signal, without delay, without mercy. And if the universe itself can turn off in a heartbeat, what does that say about the experiments we dare to conduct on the tiniest scales of reality? An alien invasion. Of all the ways the universe could end, this might be the only one we could, in theory, resist. Yet it's also the most chilling, because it's eerily familiar to both our fiction and our science. The Fermi paradox asks a simple question: where is everybody? The universe is vast, ancient, and should be brimming with life. And yet, silence. One of the darkest answers is called the dark forest hypothesis. It imagines the cosmos as a shadowed forest at night, filled with predators. Every civilization is a hunter, and every other life form is a potential threat. Revealing your location, even by accident, is fatal. Any civilization that broadcasts its existence is like a child shouting in that forest, instantly spotted by hidden predators. The only strategy for survival is silence and ruthless preemption. The reason we see no aliens, according to this idea, is simple. The smart ones hide, and the careless ones are already dead. And here's the terrifying part. Humanity has been shouting in the dark for over a century. Radio waves, television signals, every broadcast, rippling out through the galaxy like a neon sign reading. Here we are. If the dark forest is real, that makes us obvious prey. A far older, far more advanced civilization could detect our signals, classify us as a future threat, and act decisively. Their weapon might be beyond anything we can imagine. A relativistic missile traveling near the speed of light, or some technology that bends physics in ways we cannot comprehend. We would never see it coming. There would be no warning, no negotiation, just a sudden, silent end. A single decision from across the stars, erasing us completely. Another hunter eliminating a noisy child in the dark forest. And if the universe is already a forest full of predators, what lessons could humanity survive while reaching for the stars? If the universe can end in ways we can barely imagine, from cosmic implosions to invisible predators lurking in the dark, then curiosity is not just a choice, it's a responsibility. Subscribe to Strange Wise and join us as we explore the hidden forces, the unsolved mysteries, and the mind-bending phenomena that shape our reality. Every video is a journey to the edge of understanding, where science meets the unknown, and where the questions are as powerful as the answers. Click that bell, dive deeper, and never stop asking, what else is out there? And how close are we to the ultimate switches of the universe?